Here is a matching type question on general organic chemistry. Study the items in both columns carefully. Try to work out the matching before we solve it together. Let us first understand the key concept here. A Bronsted acid donates a proton. Acidity of an NH bond increases when the resulting conjugate base, nitrogen anion, is better stabilized by resonance or inductive effects. Compound I, piperidine simple secondary amine, NH with no adjacent electron withdrawing groups. Conjugate base is poorly stabilized. Very weakly acidic, pKa 35. Compound 2,2-piperidinone delta-lactam NH flanked by 1 carbonyl. The lone pair on N can be delocalized into 1C is equal to O, amide resonance, stabilizing the conjugate base to some extent. More acidic than I, pKa 25 range. Compound 3, delta-valorolactone contains no NH. The acidic proton would have to come from ACH, not relevant for NH acidity comparison. It is not a Bronsted acid in the NH sense. Compound 4, deuteramide NH flanked by 2 carbonyls. The conjugate base, nitrogen anion, is stabilized by resonance delocalization into both carbonyl groups simultaneously, providing far greater stabilization than in compound 2. This makes deuteramide significantly more acidic, pKa 10 range, similar to other imides like succinimide pKa 9.6. Reasoning: the 2 flanking carbonyls in 4 provide double resonance stabilization of the N anion, making 4 the strongest Bronsted acid among NH-containing compounds. 3 lacks NH entirely and is not competing here. Why other options fail? I has no EWG stabilization, 2 has only 1 carbonyl, 3 has no NH, 4 has 2 carbonyls giving maximum NH acidity. Answer A, D, 4. Part B, strongest Lewis base. Let us first understand the key concept here. A Lewis base donates an electron pair. For nitrogen-containing compounds, basicity depends on the availability of the nitrogen lone pair. Electron withdrawing groups, carbonyls, reduce lone pair availability via resonance and induction. Compound I, piperidine, the nitrogen lone pair is fully available, not delocalized into any carbonyl. This is a standard aliphatic amine, highly basic, pKa of conjugate acid 11. Compound 2,2-piperidinone 1 carbonyl withdraws electron density from N via amide resonance, reducing lone pair availability. Less basic than I, compound 3, delta-valorolactone no nitrogen. The oxygen in the lactone ring is the only potential Lewis base, but ester oxygens are very weak bases. Not competitive with amine nitrogen. Compound 4, deuteramide, 2 carbonyls withdraw electron density from N extensively. The lone pair is heavily delocalized. Nitrogen is essentially non-basic as a Lewis base. Reasoning: compound I has no electron withdrawing groups on nitrogen. Its lone pair is maximally available for donation, making it the strongest Lewis base. Why other options fail? 2, 3, and 4 all have reduced electron density at the basic site due to 1 or 2 carbonyls or absence of nitrogen altogether. Answer B, A, I. Therefore, the correct answer is A, D, B, A. Therefore, the correct matching is A matches D, B matches A.